Hey guys, welcome back. In today's video, we have a question that an 80-pound sheet of plywood rests on two small wooden blocks, as we can see, and it's allowed to lean 20 degrees from the vertical under the action of the force P, which we know is perpendicular to the sheet. And we know that the friction at all surfaces of block A and B is high enough to prevent the slipping, and we need to determine the magnitude of P and also the vertical reaction forces at A and B. So we're going to start with free body diagram. So we know this angle is 20 degrees and we need to show the forces that we have. So the first force, so this is Z, here's X, and this will be Y. Also, the first force that we have is the force P at point E, which is perpendicular to the sheet. So this angle that I'm showing in here is right angle. Let's see what else we have. We have the reaction at A. There's also point B. So since the friction is high enough to avoid a slipping of this sheet, we have to consider all of the forces. So we'll have AX. Same for here. We will have BY, which we know they are coming from the friction. And we have the Z component of these two reaction forces, so it will be BZ here. And last, it's the Y component, which again is coming from the friction. There is one more force, and that would be the weight of the sheet, which we know it will be at the center of the sheet. Let's call it W. And that's pretty much all the forces that we have. And let's just write everything down in a vector form. So for A, we'll have AX, AY, and AZ. AZ is one of the reactions that we are supposed to find for this question, and same for B. With BY and BZ. So we have the force P, which we need to figure out the components of this force. So as we can see, P is perpendicular to the sheet. And if we look at this triangle that I'm highlighting in green now, so this will be the right angle. And we need to figure out the angle in here. So if this angle is 20, which we know from the question that this is true, this angle has to be 20 degrees. We covered the trick in previous video that can help us find these kind of angles. So again, when we have two angles that are perpendicular to each other, so we have this side that is perpendicular to this side, and we have this side that is perpendicular to this side. Therefore, these two angles are the same. So from that point, we can find that 20-degree angle. And if we look at it, we'll see that the x component will be the p times cosine of 20. And since we are in the opposite direction of x, we'll have a negative sign in here. And since the force is in xz plane, there is no y component. So we'll have y for the j component, and simply the sine of 20 times p will be the z component. And since we are going upward, it will be positive, so we'll have p times sine of 20 degrees, and this will be the K. There's one more force that we need to find in a vector form. That would be the weight of the sheet. It only has one component along the z axis, and it will be minus w in z component. So that's everything we have for the forces. And let's move on to the moment equation. So again, we are in equilibrium, and since we are in equilibrium, we need to use our equation to find the unknowns. Let's start with the moment equation, and let's find the moment about point O, which is the origin, and let's see what we can find. So for finding the moment, we have the moment of P, the force P, we have the moment of the reaction A, we have the moment of reaction forces at B, and the last one is the moment of the weight. That's pretty much all the moments that we have. Let's find the moment of P as the first component. So we have our matrix, so we'll have, so for finding the RMP, we have R times R cross P, R cross F, well, which our F in here is P, and our R would be from O to point E, so we'll have ROE cross P, and same story for the other one. So we have ROA times, let's call it A, and we have ROB times B, and the last point is the moment of the weight. Let's call that point G, which is the center of gravity for the sheet, which we know it's exactly at the center of the rectangle that we see. So here we have ROG cross W. So let's start with the first matrix. The first matrix would be what we have for ROE. And if we look at here, from the question, we know that uh, the distance from D to E is 3 feet. So moving from O to A, I'm showing it here. So this would be our ROE. Moving from O to E, we'll see that along the x-axis, we are moving in the negative direction, but the question is how much we are moving. And what we are moving would be the distance that we are here. So if we do like something like this, we're looking for this angle, which is what we have, this side, which is what we have in there. And since we know the length of that part, so simply this will be, so we know this is 4, and if you want to find here, we will have 4 sine of 20. So for here we have for I component, again, since we are moving in the opposite direction, we'll have 4 sine of 20. For y, we'll see that we are moving from actually D to E here. So moving from O to A in y-axis, we are moving from D to E, which we know is 3. So a positive 3 here, and Z would be actually very easy to find. So for Z component, we are looking for this side, which would be simply 4 cosine of 20. So we'll have 4 cosine of 20 degrees for, yeah, I think I made a mistake here. So let's, for the I component, if you look at here, moving from O to E, we are actually moving in the positive direction of X. So we are moving actually from here to here. So there is no negative sign needed in here. So we'll be for sine of 20. And the last row of this matrix is what we have for P, which is minus P cosine of 20. There is no J component, and we'll have P sine of 20. And the second matrix that we have would be our OA. We'll have IJK. So from O to A, the only distance that we are moving is in Y direction, which we know from the question is 1 foot. So it will be only Y component 0, 1, 0. And here we have AX, AY, and AZ. Same thing for B. This time we'll move a 1 plus 5, which is 6. For Y component, again, no X and Z component, and this is what we have for the, and the last matrix that we have is the weight. And moving from O to G, so for X, it's very similar from moving from O to E, but this time we're just going half of that distance since it's a center of gravity. So instead of 4, we have 2. So for, like I'm gonna show it in here. So like it would be basically this distance that is here, but this time, so these are our variable. This time we'll have 2 instead of 4. So 2 sine of 20 will be the X component. Again, it's positive. For Y component, we have to find the length of the sheet, and half of that would be our Y. So we have 1 plus 5 plus 2, which is 8. 8 divided by 2, 4. So we'll have 4 in here. And simply we have 2 cosine of 20 as for the Z component. And what we have for the weight is just the weight of the sheet, which we know it's 80, and there is no I and J component. So from the question, we know that the weight of the sheet is 80 pounds. So we're just gonna put that in here, and that's pretty much all we have. And since we are in equilibrium, this has to be 0. So the rest is solving these determinant. Again, we only need to find the AZ and BZ since we are asked to find the Z component, a vertical component for each of the reaction forces. So let's go for the matrix that we have for I. So from the first matrix, we have 4 times 0, 4 times sine of 20 times 0 minus 3 times minus P cosine of 20. So we'll have positive 3P cosine of 20. Looking at the second matrix, we'll have AZ minus 0. The third one we have 6 times BZ, and the last one we'll have 4 times 0 minus 80, which will be 80 times 2 cosine of 20 equals 0. That's our first equation. Let's move on to our J. So for J, we'll have first matrix, we have 4 times sine of 20 times p sine of 20. So we'll have 4p sine 20 squared minus 4p, again, this time cosine of 20 degrees squared. There won't be anything for second and third matrix, and the last matrix that we have also won't have. So the weight, actually I made a mistake in here. So this will be 0 minus 80 would be the last component, because it will be the K component RW. So looking at the J component for the weight of the sheet, we will have minus 2 times 80 times sine of 20 degrees. So we can find the force P from here, which is 2 times 80 times sine of 20 degrees divided by 4p sine of 20 plus cosine of 20 degrees squared. And we know that this will be 1, and we can find P from here. So if you calculate this, we'll get P 13.68 pound. And that would be our first unknown that the question is asking. And let's go to, so from the J component of our moment, we found P. And if we go to K, let's see, from the first component, we have 3p cosine of 20 from the first determinant. From the second one, we'll have minus ax, and last one will have minus 6 times bx from the reaction forces at B, and from the weight, we'll see there wouldn't be any moment. So still we have too many unknowns, which means we need to move on to our force equations. I'm going to start with Fz since we are looking for these two components, and for Z we have Az, we have Bz, we have the weight, which we know is 80, and we also have the Z component of the P, which was, if we look at here, we'll see that our Z component for P will be P sine of 20. Equals 0. So now, if we look at our first equation for moment, I'm going to show it with I. We have one equation that has two unknowns of Az and Bz. Now we found the second equation. And from these two equations, we can find our unknowns, our vertical unknowns at A and B. And how we're going to solve this? So from the first equation, we'll have AZ plus 6BZ equal minus 80 times 2 cosine of 20 minus actually plus 3p cosine of 20 degrees. Now that we have p, we can calculate this, and if we do that, we'll get minus 3 sorry, minus 305.96. So that's our first equation. We need to do the same thing for the second one. So AZ plus BZ equals 80 minus P sine of 20 degrees. And from our fx, if we calculate that, we'll get minus 75.32. Now that we have this, it's easy to solve these two. All we need to do is multiply the second one by minus 1 and add these two together. So this will be negative, this will be negative, and this here will be positive. And if we do that, we'll get 5BZ equal minus 305.96 minus 75.32. And if we calculate this, we'll get 305. Actually, we have positive sign in here. 75.32. So we'll get minus 230.58 divided by 5. That means our BZ will be minus 46.1 pound. And now where we have BZ, we're just gonna put that in the first or second equation, would be easier. So AZ simply will be minus 75.32 minus 46.1, 5.32, only get minus 29.22. And if we want to, also the question is only asking for the magnitude, so AZ will be 29.2 and BZ will be 46.1.